Hello, hopefully all of you are doing good. Now in the previous video we have seen like how to work with page templates in Plotly Dash, right? Now let us try to build our neural network learns page, like how neural network learns page from this video onwards. Okay, so if you remember, like we had built that particular skeleton over here, right? Like we have this accordion panels over here, which we have just set it up like a overview of how we are going to build this one. Like in the step 1 we are going to visualize the MNIST dataset. In the step 2 we will concentrate on the training, and in the step 3, I think the string is incorrect over here, it should be step 3 over here, we will be concentrating on the model testing over here, right? Now in this video we will start from visualizing the MNIST dataset. So as I already explained, like the MNIST dataset is a collection of handwritten digit images over there. Okay, so we have almost like 60,000 training dataset and 10,000 test dataset available. Now if we are using TensorFlow, which we already used in one of our pages, right? So TensorFlow Keras already have the built-in built-in methods to load this particular MNIST dataset. So to know that, if you go to Keras website and if you go to this built-in small dataset, so you will find the MNIST dataset and how to load it. So this is how you will load the MNIST dataset, like tensorflow.keras.dataset.mnist load data over here. Okay, and if you want to basically keep the dataset locally into a cache, you can mention a path over here as well. So it takes only a single argument path, which is basically the cache path, and it returns 4 things over here, basically 2 tuples. The first tuple is the training related stuff, like xtrain is the number of training images. Now each and every image is 28 by 28 pixel, and there are 60,000 images over here. So it's basically returns a numpy array of this thing over here, 60,000 into 28 into 28 over here. Okay, this is the training data set, and each and every pixel value ranges from 0 to 255. Now ytrain means like the labeled images, like each and every image should be labeled over here, right? So that means it will be basically the integers from 0 to 9, the values of it, right? So as we have 60,000 images, we have 60,000 labels as well over here. So it is clear that like there would be multiple images for a particular level. Let's say for 1 there will be multiple images. For each and every digit we have it from 0 to 9, we will have multiple images over here as well. Okay, similarly for test as well, it returns 10,000 images and 10,000 labels as well here. Okay, so first what I will do is we will import the TensorFlow and we will basically load this particular MNIST dataset. Then we will try to visualize it. So we will go to our code. Now we will go to this, under the pages we have this how neural network learns.py, this particular page, right? So first we will import TensorFlow. So we'll say import TensorFlow as TF over here. Okay, so once we do that, so let me first stop the server for now. Okay, now we have imported the TensorFlow. Now we will come over here in our callback, because in the callback itself we are setting up the content of the each and every accordion item over there, right? So that we already discussed. Probably I will give that video link here as well, somewhere in here you can find it out. Okay, so that you can refer that particular video. So now we are visualizing the MNIST dataset, so we will mainly work over here, right? Because of that, which item has been selected, we are dynamically changing its content over here, right? So if you see, like when this particular accordion item is open, visualize the MNIST dataset, it's dynamically setting this particular string over here, right? So that is what we are returning over here, visualizing MNIST over here. Similarly for model training as well, it is dynamically setting this one, Okay, now the server is, I have stopped it, it did not responding, but that will happen over here, right? So let's concentrate on this visualize MNIST dataset, and then we will do it. So before that, as I said, we will load that particular MNIST dataset. Now that dataset will be used in our visualization as well as training testing purpose, so that's why I will load it before this if conditions over here. Okay, so I'll just copy this particular code. So I can copy this particular code over here. So I'll paste it over here, and only thing is that I have to write tensorflow.keras.dataset.mnist. okay, so I got our training dataset and testing dataset and their labeled images as well. Okay, let's save it. Now the next target will be how to display it, how to visualize this particular data. So we will do it through pie chart. Okay, so in the pie chart we will have different digits, right, the label digits and their counts that we are going to display both for the training as well as the testing dataset here. Okay, now to create a pie chart in Plotly Dash, as we have mentioned before when we discussed about like graphs in Plotly, so mainly we will first try to use the Plotly Express. So if any graph is not possible to create with Plotly Express, maybe we will try to use our graph object or any other stuff over there. Okay, now if you search in Google how to create a pie chart in Plotly Express, you probably land in this particular page over here. Okay, this basically tells you everything about how to create a pie chart using Plotly Express. Now the beauty about Plotly Express, using Plotly Express, is if you understand that the different inputs over here for the pie chart, probably the similar stuff, very similar stuff will be there, it will be there for the other type of charts as well, mainly like this two-dimensional data charts, something like our bar chart or column chart, something like that. Okay, so if you see, to create a pie chart, at the minimum what you need is you need some data to feed over there, right? Now what data you need, so that the data could be a two-dimensional data, something like a pandas data frame, right? Or you can provide the data in terms of names and values as a array as well over here. Okay, so the difference between this is, like, if you see, whenever we want to create a pie chart, right, so what you need, so we want to visualize our labels, digit labels. Let's say for label 1 how many images are there, for label 2 how many images are there, something like that, right? So that means we need the label name as well as their count, right? So if you have that particular data in a data frame format, you can easily mention the data frame over here. If you do not have, which is the case in our case as well, because we have it in a tuple format over here, right? So and both of this train and test are actually NumPy arrays over here, so it's basically a tuple of arrays over here, right? So we have our digit, basically the label of the images here in the train, y train or y test, and the image details, like the pixel details over here in the x train or x underscore test over here. So that means to display the pie chart, we can simply use the y train and y test over here for training and testing purpose, right? So because at the end of the day we need the digit label name and their count over here, so we can fully use the y train. Now y train is a array over here, as we can see it from the documentation itself, right? It's a NumPy array over here. Even if you are not sure, you can print that particular y train as well and see it. Okay, so that means we have an array, so we do not have that data in a panda data frame format. So either you can create a panda data frame over from there, that is also possible, or you can use some NumPy functions to convert it as like unique label name and their count over here. So that is what we are going to do it over here now. Okay, so there is a method in NumPy called unique. So it basically, you give it an array, it will basically return you the unique elements of an array. For an example, if you see it here, like if you have this kind of array over here, so it will basically give you a sorted list of array elements like 1 2 3 over here, the unique elements over here. Now this unique also accepts another, like not another, some more parameter as well. One of them is return counts. That means it will also return the count of that particular unique elements as well, which we require as well, right? So for an example, if you see this particular example, so this is the input array over here, right? So whenever you will be using unique with the return counts, it basically returns two arrays. Okay, one is the values, which is basically the sorted list of unique elements over here, as we can see it, and their counts as a separate array over here. So for 1 there is a single count, right? For 2 it basically 1 2 and 3. That's why this 3 over here. Okay, so this is what we are going to use it over here as well. Okay, so let us copy this one here. I'll copy this one, I'll go over here. Now we are basically working in this if condition over here, because this will be very specific to the visualizing the MNIST dataset, right? So what we'll do is, first we'll say train image labels. I will say labels, and this one I will just name it as this variable. I will name it as, instead of values and counts, we'll give it as good names. Okay, and it is saying numpy is not imported, so let us import that one as well. So import numpy as np, so that import issue is also got resolved, right? So now this array, this one should be our y train, right? So this one should be our y train. So first we will see what's going on with our training dataset, how we can visualize it. The similar stuff we will do it for our testing dataset as well. Okay, so we got the unique levels and their counts now. Okay, so then we can, if I just refer to the documentation of the Plotly Express pie chart, so now we can pass that label names into the names parameter and the counts as the values parameter. If you see it, like either a name of the column in the data frame, you can use it, or you can use it as a panda series or array like object over here. Okay, so the names column will be used as a labels in the chart, and the values column will be used as a values of the sectors over here. Okay, into that pie chart over there. So let us try to do that one. So what we'll do is we'll create another variable now, training figure, let's say. Okay, so first of all we need the Plotly Express, so let us import that. So I'll go over here, I will just import plotly.express as px, right? Now the training figure will be px.py over here, right? In the py, as I said, we will be passing into the in the names and values. In the names we will be passing the labels over here, and in the values we will be passing the counts over here, correct? So this will be enough to create a pie chart at least. Okay, now to visualize this one, we need to attach this figure somewhere. So what we'll do is we will create a card object, basically in bootstrap cards. Into that card we will display this particular image over here. So what I'll do is we'll search in Google dash bootstrap component. So if you go to dash bootstrap component, and into the component, if you go to card, so you will get a lot of example of how to create cards in dash bootstrap, right? So you can work with any of this like code over here. We will just try to create a very simple card with the card header and a card body. In the card body we will be basically displaying that card basically that pie chart over there. Okay, so what I'll do is, first we will create that content of the card into a variable. Okay, then we will create this particular card over here. Or let's do one thing over here. So now what I'll do is, this is the one we are returning over here, right? So let us create this one now. Okay, so we will use that bootstrap layout over here, like the columns and rows over here. So dbc, that's bootstrap component dot container. We will start with container over here. Okay, and inside the container we will have an array, and inside that array we will first create a row. Okay, dbc dot row over here. So initially this particular first row we will have two elements. One is the training data set, that pie chart. Second is the testing data set, that pie chart over there. Okay, so that means inside that row, this is an array over here. Now inside that row I will have two columns over here, dbc dot call here. So one call will be having this particular column will have the data set, basically the pie chart for the training data set. In the second column we'll have the pie chart for the testing data set over here as well. Okay, so let's work on the first column and then try to do it. So as I said, this should display a card over here, right? So if I just go over here, so inside that card, as I told, we will have a card header and the card body over here, right? So let us try to create an element over here, a variable over here. Okay, so we'll say card underscore body underscore training figure, or training. I will say, I'll just say training here. Okay, so, or instead of card body I will say card content. This will be more accurate. Okay, so we will create an array, and inside that array we will paste it over here, the card header and the card body. And the card header I will say training data set pie chart. Okay, or let's say training data set distribution. We want to see the distribution over here of those training data set labels images, right? Distribution over here. Now in the card body we will not have these things, right? So we will be displaying this particular figure over here, right? So we will be using dash core component dot graph over here, right, to display that figure over here. So in the figure we will be passing this guy over here, training figure, correct? Right, so this particular card content is done. Now this content I will be passing it over here in the dbc inside this column over here, right? So that means we need something like dbc dot card over here. So we will say dbc dot card, right? So inside the card we will be having this card content over here, correct? So, and like if you want to style it, there are a lot of styling option over here, but I will just say, if you just see the properties of the card body, dbc.card, so over here there are you can set the color, like color equals to primary, or if you also want to set some other colors, you can do that one. So let's say color equals to primary over here. I will set, even you can copy it from somewhere over here. I will just copy this one over here, then I will change it. Okay, so you can mention color equals to primary, and let's go back over here, and the outline. Okay, so this color should be applied to only the outline of that one. So it requires the boolean value, because I do not want to color the whole card over here. I just want to color the outline of that card over here. Okay, so I can mention outline equals to true. So I'll just mention outline equals to true over here. Okay, so that's the one. And let's have, so we have displayed the card, and I can mention this width is equals to 6, so that at least 2, because if I just mention width equals to 6 for both of this, so, and as we know, like, it basically the total span is 12 columns over here, right? So this one will take 6 column width, and this one will take another 6 column width over here. Okay, so let us first test it out and try to see like what's going on over here. Even like this width you can mention with that particular dictionary format as well, something like size equals to 6, right? Both are same, because here, but in this format you can mention the offset and other stuff over there as well. Okay, which we already discussed before. So let us try to see what's going on and whether this works or not. Okay, my server is ready now. So if I just go over here and see this one, nothing is displaying. It took some time to create that particular figure over here. As you can see it, like, it displayed a training data set as a card, right? And it displayed it as a pie chart over here, where each and every sector of the pie chart having this label coming from our first array, right? This is what we have developed it over there, right? If we just go back, so from this array, from these names, basically those label names are coming up, and the values of them is coming up from this count over here, which we have determined using this numpy.unique here, right? So that is what it is displaying. And as you can see it, like, for all these images, it is having almost like similar count over here, right? Most of the, like, it is having an even distribution among all these images over here. So let us try to do similar stuff for our testing as well, right? So we will do one thing. We will do using this numpy unique again, but we will be using the test. We'll be using the separate variable name over here, right? Test over here, and test image count. Instead of y train, we will be using the y test, because that is holding the image level and basically labeled images over there, right? Similarly, we will be creating a figure for testing as well, correct? So we will say testing figure, and we will be using these variables corresponding to the testing dataset, correct? This one here. And then similarly, we will be creating a card content over here as well, right? Instead of training, this name will be testing dataset distribution, and instead of training figure, it will be the testing figure over here, correct? The testing figure over here. And in my second column, I will be having another card, correct? But this will have the, so let's name it as testing over here, testing, correct? So we will copy this one, this content over here, which will basically display the testing image. We'll also mention the width of this particular column as well here quickly, right? So if everything we have done correctly, so it should have the second image over here somewhere displayed, which will display the testing distribution as well. Okay, so you can see it, like, it is having like similar distribution as we can see it from the testing as well, right? But it is having lesser count, because we have only 10,000 images available for our testing dataset, and we have over here almost 60,000 images available for our training dataset over here, right? Now it would be good if we can display somewhere that overall count of images over here, even though we can add up all this count for different unique images, labeled images over here, but it would be very good if we can display count somewhere, like either inside the chart or somewhere over here, right? So probably we will do it inside the chart so that it will be very much good and we can see it properly. That means we need to convert this pie chart into probably a donut chart, right? And then inside that hole we are going to display that particular overall count. Here it will be 60,000, here it will be 10,000 over here. So how to convert a pie chart into donut? It will be same documentation we will go, right? And if you go down, if you see there is a input called whole, right? So it sets the fraction of the radius to cut out from the pie. Okay, so use this to make a donut chart. So it is very simple. So in the whole we will be giving some fractional value over here. So what I will do when we are creating that figure, right, for let's say here I will give an input called whole and I will say 0.3 over here. That means like 30% of the radius will be cut out as a whole, right? So if I just do this one, now what will happen? Let's see that. So now this pie chart should become a donut chart over here, as you can see it, right? So now we can display our overall image count over here, which we will cover in the next video because there are certain things we need to discuss over there. Okay, but at least we can easily convert a pie chart into a donut chart over here. Okay, so at least in this video we learn something like how to get the MNIST dataset, how to load the MNIST dataset programmatically. Then we learn about how to create pie charts and donut charts very easily using Plotly Express, right? In the next video we will try to update these charts and we will try to display our overall count somewhere in the middle of this particular chart over here. Okay, so that would be a fun stuff to do and we will do some more stuff as well, okay, in the later videos as well. We will try to visualize a particular image as well there. Okay, so because if you see it like in the keras, so what it is returning from the using the xtrain, each and every element of the xtrain is an array, right? This one with this size 28 into 28 over here. So we will try to visualize each and every, not each and every, but at least some of the images in the training dataset as well as some of the images in the testing dataset as well. Okay, so hopefully this video was helpful. See you in the next video.